Hi and welcome. I am Lakshmi Gullapagod, Senior Assistant Professor, MIT, Moodbidre. Today in this session, we are learning Module 1 Single Random Variables. The topic that I am covering are binomial distribution and the exercise problems. This video session, I'll be naming it as Lecture 1.4. In Lecture 1.2 and 1.3, we have learnt two different types of distributions, uniform distribution and exponential distribution. In this lecture 1.4, we'll study the binomial distribution. Let us start. So before knowing what is binomial distribution, we need to have a look on Bernoulli trials. It is a random experiment in which there are only two possible outcomes, success and failure. Examples, tossing a coin, you have only two possible outcomes, head and tail. So the occurrence of head can be considered as success event and occurrence of tail can be considered as failure event. Second example, in production system, the defective products can be considered as success event and the non-defective items can be considered as failure events. You can also go with vice versa. Third example, phoning a call center. Success can be considered as operator if free, failure if the operator is not free. The Bernoulli random variable x takes only the two possible values 0 and 1. 1 representing the probability of the success event. The 0 represents the probability of failure event. The probability of random variable x, capital X, is equal to 1 represented by small letter p. The probability that random variable x is equal to 0, that is failure event, is given by 1 minus p. The sum of the probabilities, the x is equal to 1 probability and x is equal to 0 probability is always 1. P plus 1 minus p will give you answer 1. The probability, the total probability of the experiment, Bernoulli random variable experiment, is equal to 1. It can be easily checked that the mean and variance for Bernoulli distributions are represented by E of x is equal to small letter p, the probability of success, and variance represented by V of capital X is equal to p into 1 minus p. Here p represents the probability of success event, 1 minus p represents the probability of failure. You can even write 1 minus p as q. Consider the following random experiments. The experiment consists of n repeated Bernoulli trials. There are few random experiments where they consider n repeated Bernoulli trials. But each trial has only two possible outcomes labeled success and failure. And to note, the trials are independent. That is, the outcome of any trial has no effect on the probability of the others. Remember, the trials are independent. The probability of success in each trial is constant. In spite of n trials, the probability of success in each trial is always constant, which is denoted by P. In probability and statistics, the binomial distribution with parameters n and p is the discrete probability distribution. Remember, the binomial distribution is discrete probability distribution because the outcomes are finite. The outcome of this random variable x event is always finite, either the success or failure, true or false. Hence, it is a discrete probability distribution, or it can be like yes or no question kind of event. Each outcome always represented by Boolean values 0 and 1. The probability p, small letter p, is the condition for success, yes, true, 1. And the probability Q is equal to 1 minus P represents the failure no, false, 0. The single success failure experiment is called Bernoulli trial or Bernoulli experiment, and sequence of outcomes is called Bernoulli process. For single trial, here n is 1, then we call Bernoulli experiment. If you have more number of trials, then we go with the binomial distribution. Let's look into the definition of binomial distribution. The random variable x that counts the number of successes represented by k in the n trials is said to have binomial distributions with parameters n and p, written bin bracket k semicolon n comma p. Bin represents the binomial distribution, k represents the number of success in the n trials, n represents the number of trials that experiment has, then p represents the probability of success event. The probability mass function of a binomial random variable with parameters n and p is given by f of k is equal to probability of random variable x is equal to k, which is equal to round brackets. Within round bracket you need to write n k into p power k bracket 1 minus p whole power n minus k, where k ranges from 0, 1, 2, 3 so on up to n. The term here n k in the round brackets represents the counts, the number of outcomes that include exactly k successes and n minus k failures. So let's look into the formula list for solving the exercise problems. The binomial PMF is given by small letter f with subscript capital X bracket small letter x, which is equal to summation k is equal to 0 to x n ck p power k 1 minus p n minus k power n minus k into delta x minus k, where your n represents the number of trials, k represents the number of success, p represents the probability of success, 1 minus p represents the probability of failure. Okay, and the binomial CDF, the cumulative distribution function, is given by capital letter F with subscript small the capital X bracket small x, which is equal to summation k is equal to 0 to x n c k into p power k 1 minus p whole power n minus k. Here the summation represents that we are considering the discrete distribution. Okay, the random variable has discrete events, discrete values. So you observe the difference in the above two equation. In PMF you have the additional term delta into delta x minus k, whereas in CDF we don't have that term. Okay, so the mean of binomial distribution is given by mx, or you can also write it as mu x, which is equal to n into p. The variance of binomial distribution is given by sigma x square, which is equal to n into p 1 minus p. The standard deviation is given by square root np into 1 minus p, which is square root of variance. Let us consider an example here. A biased coin is tossed 6 times. The probability of heads on any toss is 0.3. Let x denote the number of heads that come up. Calculate probability that x is equal to 2, probability that x is equal to 3, the probability that x is greater than 1 but less than or equal to 5. Here, read the problem carefully. You will get to know whether this problem belongs to binomial distribution or not. Here, they are tossing the coin 6 times. That is, number of trials that they are having here is 6. That is, n is equal to 6. The probability of heads on any toss is 0.3. That means we have only head and tail. The probability of head is given to us, then we can definitely say that it is the the experiment that follows the binomial distribution. So the probability of head occurrence is taken as success event. So the P is equal to 0.3. So then X denotes the number of heads that come up. So to find P of the first one, to find P of capital X is equal to 2, the formula just now I said bracket NK, N is 6, K is 2, then close a bracket and into P power K. P is 0.3 whole power K. K is 2. How we got it? X is equal to K. The K is here 2. So into 0.7 times power 4. Here 0.7 you got it by writing 1 minus P. 1 minus P is 1 minus 0.3 which will give you answer 0.7 whole power N minus K. N is 6. 6 minus 2 will be 4. So you just need to find what is 6C2. 6C2 is 6 factorial divided by 6 minus 2, that is 4 factorial into 2 factorial. Do it, you will get the answer. Then similarly for P is equal to X, P of X is equal to 3, you need to consider K as 3. Substitute in the formula NK, N is 6, K is 3. Then you will get P power K is 3, then P is 0.3. 1 minus P 0.7 answer whole power N minus K. N is 6, 6 minus 3 will be 3. So you get the answer 0.18522. Similarly, for the probability between the range 1 to 5, you need to consider the 4 possible probabilities. X equal to 2, 3, 4 and 5. You may ask me why only X is equal to 5. Why can't we go with 6? Here they have given a condition less than or equal to 5. Hence stop it at X is equal to 5. Using the same formula, the method that you followed for finding X equal to 2 and X equal to 3, you need to find similarly X equal to 4 and also X equal to 5. You will get the answers, add them and you will get the final answer as 0.578. So let's look at another example problem. Suppose that 5 digits are transmitted over a noisy channel with per digit error probability of 0.01. What is the probability that up to 2 digits will be in error? Also calculate mean and variance of the error. So here we need to consider the 5 digits are transmitted over noisy channel. That means what? The n is equal to 5. And what are they asking you to find? The probability that up to 2 digits will be in error. So that is k equal to 2. And what is the probability that the digits are transmitted with error? It is given 0.01. So hence probability of error per digit is 0.01. The probability of correct digit will be 1 minus p, which is 0.99. K is number of digits. They are asking you to find the probability with 2 digits in error. So the k is equal to 2 and you will have n is equal to 5. So now substitute in the equation the probability of x is equal to k nc2. Then you will get here p is 0.01 whole power 2. 1 minus p is 0.99 whole power n minus k. Here, what is this? 5c2. It is 5 factorial divided by 5 minus 2. That is 3 factorial into 2 factorial. Multiply all the values, you will get 9.7 into 10 power minus 4. They also have said to ask you the mean, which is given by formula n into p, which is 5 into 0.01. Answer is 0.05. The variance for binomial distribution is np into 1 minus p. N is 5, p is 0.01. So 1 minus p is 0.99. Multiply, you will get the answer 0.0459. So also the standard deviation is asked. So find the square root of the variance. You will get the answer as 0.22 as the answer. Here, I just want to make a note here. The previous exercise I have shown you the different notation for finding the probability, where I wrote here as 5 in round brackets. I wrote 5 2, which is nothing but 5c2, the combination for finding the 5c2. Okay, so which is 5 factorial into c minus 2 into 2 factorial. So remember this. Both the notations can be used. But you should know that the notation bracket n k in column, whatever you have wrote in the previous, you saw in the previous slide, is equal to nck. nck is equal to n factorial divided by n minus k factorial into k factorial. Thank you.